All right, so we covered step 104, I guess, within our Django project. We've created our models. We definitely spent some good time on it, had some good discussion, but our models should be squared away now. We have the appropriate fields and data types that we want. So our next challenge and our new item, new kid on the block, is the idea of serializers. Today, we're going to do this all manually. We're going to create our own serializers, see how we kind of package up data. It's nothing too complicated, even though it's a decent amount of code, but it's not really anything that's going to be mind-blowing, to be honest. So again, serialization sounds like a fancy term. It's really the idea of, again, just converting some data representation into another format for that data. All right, so let's get to serializers. And for that, I'm going to create a new file in my app. So in my Netflix app, I'm going to create a new file and call it Serializers. This is a naming choice. This is not a Djangoism. So I do not have to call this file anything in particular. I'm just choosing to call it Serializers because, hey, I'm going to add my serializer code in here. So to start, I'm going to create a class and call this Serializer base. Yeah, actually, let's just do it piece by piece. So I'm going to create a class and call this category serializer. The job of this class is to take in internal data, so Python data structures, and convert it to JSON format. That is what the goal of this class is. So for category serializer, I'm going to add two methods. One's going to be define serialize all. Again, these are just naming choices. If I could type what I say, serialize all. And then that's going to be an instance method. So we'll do self and item list. Okay, this is basically going to take in a list of Python objects and serialize all of them. So again, pretty straightforward. It's going to be a for loop. So we'll have serialized data as our return value. And then we'll have a for loop saying for item in item list. Let's serialize each item and append it into serialized data. So I'm going to append a function call. So we can do this kind of piecemeal if we want to. Serialized item. So this is going to call some function called self.serialize, which we have not created yet. I'm going to pass the item to it. We get serialized item back from it, and we'll append that into our serialized data. And then finally, we'll return serialized data. All right, so nothing too complicated. We just get a list, iterator of that list, call some function, store the return value, and return another list. All right, our actual method, or method that has more actual stuff in it, is going to be the serialized method. So the goal of this, this function is going to be taking an item. Again, this is going to be a Python data type, and we're going to convert it to a JSON format manually. So here we could return, it's going to be a category item. So category item, I guess we should call this category list. Sorry for all the naming changes. It's going specific to generic. So specifically, this is category list. So all of these are going to be, let's call it cats. Any cat fans out there? Okay,
like
so
cats.
What was that?
Oh, you said is there any cat fans? I was like, I like cats.
Okay, sorry, I have trouble picking up your audio, Lyman.
I thought you said, is there any cat fans out there? And I said, I like cats.
Oh, yes. So, gotcha. Yes. High five. Cat fans out there. All right. So serialize, we'll take in a category object. And all this is going to do, again, simple function. We're going to return a JSON formatted object. So in this case, category ID will return, we got a type. Category type was field. And then maybe going back to John Winko's question, another advantage of having a separate model for categories is that we have that reverse relationship right off the bat. So we have products as a reverse relationship. So I could do category.products. And we'll have to talk about this in a second. So this is what my serializer will look like for category. We have one method that will take in a list of categories. The second one will basically just return a JSON representation for a category object. Now, a couple things to mention. Django and Python both have built-in functionality to do something similar. So in Django, I just want to point out, just for discussion's sake, there is from Django. Where is it from? From core, this core has everything in it, import serializers. So Django has built-in serializers. If I want to use this, I could do something like data equals serializers.serialize. Format will be JSON. Again, this is all from documentation, but if I had a category model, category.objects.all. So this is a built-in Django serializer, which will do essentially the same thing we're doing here. So this may seem like, hey, this is much quicker. Why are we doing this ourselves? Well, two reasons. One, we want to see how to actually manually do this and get practice with doing it the hard way. Second, this built-in serializer is not meant for external data representation. It is used internally by Django to represent data internally, as in the format is not meant for external consumption. So that is what the internal serializer is used for, can be used for. We could get away with using it for external data representation, but it's not going to be formatted in the way we necessarily want. This allows us to have full control over how the JSON format is created. We can specify the field names. We could specify how the values are formatted. That's all up to us when we do it manually. Looks like I need to import a few items here, though. I guess I don't have a category model here, but that is one thing I wanted to point out. Django has built-in serializers, but we're not going to use them. Second thing is Python has this JSON module that is useful for, you could do JSON dot, I think, load, what is it? From JSON import. I always forget my syntax here, import JSON. So there's a built-in JSON module that has a bunch of functions. You do like JSON dot loads. Yeah. So load and dump, I think, are the functions. These let you go back and forth between serialized data and internal data. These only work for basic data types. So these would work if we only had like, dictionaries and lists and integers and strings and bools and whatever. So this would be great if that's all we had to work with. But these objects are not any basic data type. These are objects of our classes. The JSON method, the JSON module, does not have an easy way to just automatically convert our custom objects to JSON format. So that is why we cannot just rely on the default JSON module, even though it's great. We're going to use it at some portions, but for our internal objects, we need to manually convert it to JSON in this manner. Any questions about those segues? Okay, so that is my category serializer. There are some things I need to consider here, and the portion I've highlighted right here, this will not work. This needs work. Because products.all is going to return a query set. That is, again, a Python object. We can only send basic data types back in JSON, right? So we only send strings or integers or lists, I guess, or dictionaries. So that's what this is. It's going to be a dictionary. But we cannot send a query set back. That is a Python data type. That is not a JSON data type or a basic data type. So this needs work. We can't just return products.all. So one easy fix here is I could just return the ID values of these products. So what I'm going to do, I'm going to do p.id for, do some list comprehension here. Hopefully you guys remember that quick tool. Need a closing bracket. So now we're just going to return all right, so that is one option we have here, is to simply return the IDs. And this is the common case. And I'll admit, I've made our tutorial a little more complicated than it maybe it needed to be, but just to show what we can do with our own serializers. So here, this is a simple case where we just return IDs, task is done. We'll talk about a more complicated case in a second, but for now, I'm just going to move on with my other serializers. So if I want to create like a class for genre, a serializer class for genre, I'll do genre serializer. Again, if any questions pop up, let me know. All right, so genre serializer, it's going to be sort of similar. In fact, so similar, I'm going to decide, instead of copying this block of code, putting in a genre serializer and kind of changing just variable names, this function is super generic. It can take in any list of items, and all it's going to do is going to call serialize based on which class we're in. So this is where we're going to use our OOP tools and use inheritance here. So instead of repeating myself for each serializer and creating the same function that's basically the same, I'm going to create a base class, say base serializer. All right, so again, hopefully you guys not forget your OOP concepts, but idea here, I'm going to move this function into my base class. And this is where I do want to make it more generic. So going back and forth with naming. I don't want to call it category here because it could be any model. So I'm just going to call it item because item's a generic name. So item, no more cats. Cats go away. All right, so this is, again, a generic enough function that I could create a base class, and then I can inherit from that base class. So again, just a quick review of how this is going to work. If I create a category serializer instance and call serialize all on it, it's going to go through this logic, and it's going to call some function called serialize, which doesn't exist in the base serializer, but each of the derived classes is going to implement serialize for me. So when I call self.serialize from this level, it's actually going to go up to the category level and find a function called serialize. Okay, so I'm going to do the same thing for genre serializer. I'm going to create a serialized method. So each serializer class needs to implement its own serialized method because the data is going to be different for each what do you might call it, each model. So in this case, we have genre. So I'll name this appropriately just to make the naming better. We have a genre ID. We have a genre type. Genre. We have products also. Genre. And then we also have a tagline as a field that I added. All right, so again, inheritance saves us from writing the same code over and over again because now we're inheriting base serializer should be inherited for every other serializer we create. So now genre serializer and category serializer have access to a method called, each instance will have access to the instance method that is called serialize all. All right, any questions there? Okay, just to expedite this a little bit, I'm going to copy some code from the curriculum page because I don't want to type all this. It's a lot to type. This is my, so I have a naming change here. Because I called it serializer based on the curriculum page, so I'll go with that. All right, so we have our product serializer, which has a lot more fields in it. In fact, I created some static methods to kind of convert the Python objects into IDs. So notice I'm just doing list comprehension in these functions. There's a reason I broke this out into functions. But so these are all the fields I'm sending back. Some things I want to point out here. Like we have ID, we have title, right? These are things coming from our model. So they go back to our models.py, right? Our product model had fields for description and genre and image URL. So those are things I'm sending back in my serialized data. But additionally, we can send any additional fields we want to. So notice I have a field called average rating, which is calling that function that we created before, get average rating. This is not part of our model. This is not stored in our database, but we are presenting this as additional data in our serialized data that we're going to send out of our application. So again, we could add as many fields as we want. I could add nonsensical fields like donuts, yummy. Like, again, this is just data we are sending out. It does not have to always map to your database. We have control of how we want to send out the data. So that's what it's being done here. So we have a couple functions we're calling serialized reviews, which again just gives us the review IDs. These are static methods, meaning this has no impact based on the instance or the class. These are just helper methods that take in something and return something else based on the input. I'm going to pause here because we kind of copy and pasted a lot of code here. I'm going to stare at this for a second. Any questions about this serializer right here? Elon.
Do you mind going over how did you inherit the base class function into the other two again?
Yeah, sure. So I created a base class, which is highlighted right here. Only thing this base class is providing me is a function for any other class that derives from this class. So these are my model serializers. So category serializer, because it's inheriting from serializer base, formerly named base serializer, it has access to this function, meaning if I have an instance of category serializer, right, I create an instance of it, I can call c.serializeAll and pass it a list of categories. So, some list of whatever the list might be. So I have access to serializeAll because category serializer inherits from serializer base, meaning serializeAll is an instance method that every instance has access to. So that is true for any genre serializer instances and now product serializer instances, because all of them inherit from the same base class, meaning serializeAll is accessible for any instance that I ever create for these serializers.
And also, those two individual serialized function, are those just like separate function that returns whatever information came from those table or class?
Are you talking about these methods right here?
Yes.
Yep. So again, the high level goal of our serializers is to take in Python objects and return JSON formatted objects. So this is a dictionary, but a dictionary is something that can be translated to JSON easily. We cannot translate a category instance to JSON automatically. Again, we talked about that. It's a complex data type that there's no default mapping. So we are manually telling our application how to map a category instance right here that's passed into a JSON kind of formatted object. So that's what each one of these methods, serialize, is doing. The reason I've named all of them serialized, there's a purpose for that, is because through inheritance right here, I'm calling a method called self.serialize. This does not exist in the base class. If I create an instance of serializer base and called serializeAll, this would blow up. This would not work because self.serialize would not make sense in the context of a serializer base object. But for a category serializer or a genre serializer or a product serializer instance, self.serialize, that function is going to exist because I've specifically named the derived class instance methods serialize. If I name this something else, this link would break here. Self.serialize will no longer find the appropriate method in the derived classes. Okay, we got one more serializer to throw in here. Nothing too exciting, so I'm just going to copy and paste it. It's going to be our review serializer. All right, so it looks like a lot of code again, but it's very simple in what we're doing. We're taking in a Python object, spitting out a JSON object. That's it. That's what serializers are for. I saw a hand raised. John Price, question, comments?
Yeah, hey Ankur. So yeah, it's been a while since I looked at OOP. Can you explain the difference between a class method and a static method, just as a refresher?
Sure. We have some static methods down here. So this is a very simple static method. There's a reason I created these methods. They may seem kind of silly right now, but I will. I swear there's a reason why I created these methods instead of just doing. I could have just done product ID right here, right? That would work, but I'm kind of thinking ahead because I already have this planned out. So instead, I'm calling self.serialize product up here, and then I'm calling a static method. So John's question was, what are static methods? And let's review all three types of methods. We have instance methods, we have class methods, and we have static methods. These are three types of methods we could have inside of a class. Instance methods rely on the existence of, I can't spell, of an instance. So again, as the name would imply, you need to create an instance of the review serializer class to access this method right here. Because this is an instance method, we need a self to exist in order to call this method and do something on it. So that's what instance methods are for. Every instance you create wants to do something when they call this method. Class methods don't rely on any individual instance. So a class method is used for like, what if I want to do something for every review serializer instance? Like what if I had a class level attributes and say something equals blah. I could create a class method that interacts with the class level attribute. So in that case, I would need a class method, which would look like this. Class method. CLS is the input, the first parameter, and then we could do whatever else we want here. So a class method compared to an instance method doesn't take in self, but it takes in a reference to the entire class. So CLS right here, and I'm not sure why I'm failing my syntax here. Oh, sorry. Okay, so class method, that decorator says this is a class method. It can be accessed without an instance existing, meaning I could do something like review serializer dot method name. This is fine because this is not an instance. This is a class that exists, and I could call that method, that class method off of the class. No instance needs to exist. I cannot do the same for this. Would not make sense. It might accidentally work, but I cannot do this. This wouldn't make sense because this is an instance method. I guess upon reflection, this could be a class method, but I've decided to create it as an instance method. But again, class methods still want some reference to the class. So CLS refers to which class is calling it, and you can do additional things there. So in this method, I could do CLS dot something, which is my class level attribute, and have access to it. Static methods don't care about any other details about your class. Don't. Static methods are just helper methods that we've nested within a class, just because organizationally it makes sense. So like this method right here could exist outside of my class, but I've nested it inside my review serializer. So I need to tag it with a static method to distinguish it from an instance method or a class method. So no decorator means it's an instance method. Class method decorator means it's a class method. Static method just means it's a helper function that does something related to our, like tangentially related to our class, but doesn't need to know about any instance methods, any instances, any class methods, any class attributes. I don't know if that was helpful or just a lot of word vomit, but that's what this is doing. We take in something, spit something out, has no impact on self or CLS. Was another hand raised? Jesse.
Yeah, I have a quick question about, I'm just looking at your return statement from, I guess from line 66 and down. And I'm looking at product, and I'm just trying to, why are we doing the self.serialized product with the review.product in those? I'm just trying to understand that piece.
Yeah, so that's some mystery here. So this makes a little less sense. If you go back to our previous example for product, we just created some helper functions that takes in a genre. So in this case, this is a many-to-many relationship. If you guys remember, this is a many-to-many, right? M to M. This is a one-to-many. I don't know if these are official acronyms, but in this case, I guess this is not a good case, but in this case, we have many genres that we need to serialize. So in this case, we are not allowed to just put in products.genres at all, because this is a query set. This is a complex data type we want to return simple data types. So just strings, integers, any of those basic data types. So here we need to convert this query set into something that we could send out in JSON. So to do that, I've created a function that simply accepts a list of genres. So it takes in a query set of genres, goes through it, and just returns the ID for each of those genre objects. So an ID is just going to be an integer. That's a simple data type. So it's going to be a list of IDs that we return. And a list is a basic data type. An ID is a basic data type in terms of JSON. JSON can represent lists and dictionaries and integers, strings easily. The reason I have functions here is for my next point, which will make this a little more complicated and sort of regretting it because I know we're kind of getting already pretty deep into this. But these are my initial serializers. They take in an object, convert it to JSON. Again, that's all serializers are doing. So let's get rid of all this fluff. So this is the simple case. This is the normal way stuff is serialized, but doesn't have to be. Where if we have a nested relationship, meaning category has a bunch of products, instead of returning the product details, all we return is the ID. And then again, if you kind of extrapolate this out, we did this with Hacker News, I think yesterday or 2 days ago, where you make an API call, it just gives you a bunch of IDs back, and you use those IDs to make other API calls. For example, when you hit up, a section or a category in Hacker News, it gave you like 100 IDs back, and then you can make another API call to say, hey, give me the article detail on ID 74537, right? So that's kind of one design that we go with. And that's what we're doing right here, where we're saying, hey, we have a bunch of products that each category is associated with. We're going to give you the product IDs. If you want more information on those products, well, guess what? You're going to need to call into the product serializer with each product ID that you have, or I guess each product instance. I'm going to pause here because I feel like we've been typing a lot, talking a lot. I want to make sure there's no other questions we're omitting here. Okay, so this is where I'm going to spice it up a bit. And again, hopefully you guys won't hate me for this. Again, I know this is hard enough to kind of understand a new topic, but this will work for any design that we might want to create. But I want to just customize this a little bit more. And this is where I'm going to create more serializers. We create as many serializers as we want. So I'm going to create another serializer and call this category nested serializer. And this is actually going to inherit from my original serializer. So I'm going to use inheritance, and hopefully we understand our OOP concepts here. We're going to inherit from category serializer, meaning everything that category serializer has access to, including its base class, we're going to get access to that in any category nested serializer object that we create. Okay, so this is going to do something a little differently. So before, for my category serializer, I simply had one way of representing my products, but I want to have more than one way to do that. So that's why I'm going to create a static method to separate out that logic and do def serialize. I was having trouble spelling and typing, or talking and typing. Serialized products. That's going to take in products and return exactly what I have here. Now, again, if the question still is in your mind of why am I creating a separate function, we're going to see that in like 20 seconds once I call this function. So I'll do self.serialize. Guess I have an extra R there. We want to pass in this garbage. All right, it's category products.all will be passed in here. Okay, so I'm calling a function here that's going to return a list of IDs. That's for category serializer. My category nested serializer is going to do something a little differently when it comes to products. So I'm going to copy this function. Again, the function name has to be exactly the same as before. So my base class has a function called serialized products. I'm going to create another function with the same exact name in my derived class right here. But instead of returning the IDs, I'm going to do something a little differently. I'm going to return product serializer, serialize all products. All right, what are we doing here besides returning twice? Now we have two functions based on which category, which serializer class we are using. If we create an instance of category nested serializer, we're going to return something different when we try to serialize our products. Instead of just returning a list of IDs, which we're doing with our category serializer here, when we go to serialize an object, we call a function. And if we're using a nested serializer, this is the logic that will execute. In this case, we are calling another serializer for that data. So we're going to nest serialized data within other serialized data. So instead of just getting the product IDs, this will give me everything that my product serializer, where'd that go? It's going to serialize products and give me all this data back that I'm serializing my product serializer. So instead of just having the ID, I have access to the title, description, category, genres, etc. I have the full detail of the product in my serialized data. So this gives me more detail if I want it when I serialize my category. So again, we have a category object, but within that we have a bunch of products. If you want to see all the product details, we want to use our nested serializer, which will actually package up the individual product objects using the product serializer. So that is why I created this function. So we use inheritance and call the appropriate method based on which type of serializer we created. Is it the nested serializer? Yes, then we go ahead and kind of dig deeper and serialize additional data. If it's not the nested serializer, well, then we don't want to get too deep. We just kind of return a list of IDs and that's it. Kind of keep it flat. All right, I know I talked a lot there, so I'm going to do some more more addition here, but while I do that, definitely good time for questions. Lyman?
So I guess like the reason you would do that just depends like where you're at in your application about how much data you actually need to request. So in some instances, you don't necessarily need all that product data. So that's why you're just in that format, you're just creating a list of IDs and you can grab that data as needed versus pulling in all the product information, right?
Correct. Yep. Again, nested serializers are more probably rare and commonplace because they do require more data to be transmitted. So you're not going to usually take this approach, but I just want to show that it can be beneficial because we are in control of how we're sending our data. So here I create a nested genre serializer. In this case, I want to override a function in that. So serialized products, I want to call that right here. Self.serialize products. So again, nested serializers, I know that's going to complicate things from our initial understanding of serializers, but just understand we're kind of repackaging additional data using other serializers kind of inside of our existing serialization logic. So we have genre nested serializers. I'm going to do, again, copy and pasting from the curriculum page to save a bunch of time, save your time and my time, and avoid any typos. So again, we had 3 functions in our product serializer. Those all will be overridden by our nested serializer so that, again, for category, we're going to use a category serializer to serialize that category. So we get additional details for the category. We have genres, which is a many-to-many relationship. We also have reviews, which is a one-to-many. So we have a bunch of reviews we want to serialize. We're going to call the review serializer for that. Important thing, the reason we need to go with this design is to avoid infinite looping. Notice I'm calling category serializer here and not calling category nested serializer here. This is a big design point to make here. If I called category nested serializer right here, right? So let's say we're serializing a product instance. We're going through this logic. We get to category. We say, okay, cool. We got to call this function. That function is going to jump up to our nested serializer right here and say, all right, we need to serialize the category by calling category nested serializer. In this case, we got to go over and check out the logic for category nested serializer. So let's go over there. Category nested serializer is over here. Let's say this is nested also. So category nested serializer says, all right, let's go ahead and serialize that category we got. But to serialize products, we are going to call product nested serializer. Okay, we have a bunch of products. We need to serialize them. Product nested serializer can do that. So we pass it a list of products. Let's go back to nested serializer, product nested serializer. Okay, we're back here. Great, we have a bunch of products we need to serialize because we had a product. The product had a category. the category has multiple products associated with that category. So now we're serializing all the products in that category. Well, cool. We're going to go through each product in that category of products, and we're going to go through doing this again. And then great. Well, now we have a category for each one of those products. I know there's a lot of wordage, but basically we're going back and forth between serializers as the end result. So for our nested serializers, they should not call any other nested serializer. They should just call the normal serializers because we don't want to go back and forth between serializers. So here, again, don't want to call the nested version. We want to call just the normal version so we don't get into that infinite loop back and forth, serializers calling other serializers back and forth. All right, so that's why we created nested serializers and normal serializers. So we don't have to get into some weird infinite loop. All right, one more serializer I want to drop in here. Courtney, question.
Can you walk us through the way that I know you just walked us through the nested way, which was not the way that we want to do it. Can you walk us through the way that we would want to?
So you're talking about just ignoring nested serializers?
No, I guess if you're starting with that, but like with the right way to do it, like, can you just go, I don't know if that makes sense. But.
Sure. So again, the idea of nested serializers, I wish I had data to show you. I'm kind of doing all of our coding and I'm going to see how these actually work. Maybe I should have some examples, again, just throw on the screen. But if let's say we have a given review. A review is composed of 4 fields. So let's say we have a review object. We're going to have a rating, a username, a comment. These are all just normal fields. Can be integer and some string values. Those are easy to serialize. But a product here has more to it. A product has all of this information in it, right? So when we go to serialize the review object, we have 2 options because we have 2 serializers. One is simply store the product as an ID, a product ID. That's the easy case. But the more complicated case is, well, what if we want to nest the product information within the review information? So effectively, I guess I could kind of write this out in serializers. Right here, we're serializing a review object. Product is going to look like a dictionary. So instead of this, it's going to be, now we're going to have title, whatever the title is. And then we're going to have description. Obviously, I'm not going to write all this out, but these are all the fields for the product that exists. We also have ID from each product. Don't want to forget that because that's important. Say it's 1. Description. All right, so this is what our review serialized object will look when we use nested serializers. It's going to contain the nested products being serialized. So that's, again, if we use the nested version, because notice we're calling another serializer here. If we use the normal review serializer, our serialized product returns just the ID instead of calling another serializer here. So in this case, if we use the regular old one, this will simply be an ID that we return. All right, so again, we'll see this when we actually have more suitable data. But again, the nested one is going to have more nested data, kind of different layers of it. The review one is going to be more flat. It's just going to represent any nested relationship with IDs, and that's it. It's not going to get you any more data in that case. Saw another hand. I missed the name. Sean, question?
Yeah, so I guess like you said, the easy way would just have the product return the product ID and then do another API call for the product ID to get that info, right?
Absolutely. Yep. That is typically the way sites will be designed, but not always. There are APIs that give you like huge chunks of data instead of just IDs. Review.product. Okay. So again, I know that's going to be a little complicated, going to take some time to digest, but just understand nested serializers give you more data. Review serializers just give you IDs if you want to simplify it to that. Okay, so that was a lot of talk on serialization, but again, complicated word to say, very simple concept. Take some internal data representation, in this case, Python data types, and convert them to JSON appropriate data types. So in this case, a dictionary is a basic data type. So again, JSON data, if I want to just put a comment here, JSON can handle dictionaries, lists. These are basic data types, also int, string, there's not that many: string, bool, and I think null are the 6 basic data types. So here we have converted our object to a dictionary. JSON can take over from there. Okay, so any questions on serializers? Again, a new concept. This is the main new concept for today. So happy to take any amount of time to kind of just understand what we're doing here. There are some design choices that I regret with what we came up with, but it's going to work. I'll probably change that up when I look at this again in the future. Any questions though?
So whenever we're doing this with the nested serializers, is it just best practice to always have just a base serializer started? And then if you know that you're going to be calling nests, to just do them afterwards on a different class?
You had me for most of it. So yeah, so usually you want to create your simple, I don't know what I'm doing there. Your simple serializer, I call it the flat serializer, meaning it's not going to recreate or go dig deeper. It's going to keep everything at like relatively the same depth. So yeah, create that base one. And then if you want to have a nested one, create another class that will call into non-nested serializers. Again, you want to avoid that back and forth. I don't know if I understood your question appropriately though, John.
It's just kind of getting into DRF a little bit later on, whenever we're having some of that's taken care of for us. As just best practice to the ones that you know are not going to have any fields on it that you're going to use other classes for, have all those at the beginning. That way you can use them later on in your serializers.
Sorry, I'm struggling to understand or trying to picture your question. I want to say yes, but I'm having trouble processing right now.
When we get to break, I'll just throw up a screen
Okay.
thing for you to look.
Gotcha. Thanks. All right, cool. So those are serializers. I think we've done our due diligence there. So probably a good time for a break. We do have 2 more things to get to. So where are my notes? So we completed serializers. The next thing is creating our views. That's going to be another large chunk. URLs will be super simple. There's not too many URLs we're going to create. Views, we're going to talk about how to kind of create those, how to create some generic functions so we don't have to write as much code, but we'll do that after the break. So it is 11 o'clock. Let me stop this.